It says, and again, a like will be again if you like the video in the end, only when you're going. It says that you're given an unsorted integer array nums. So every word has a meaning. If it would have been sorted, maybe some different time complexity would have been there. So it is given, it is unsorted integer array nums. Okay, usually the array is nums. We have to return the smallest positive integers that is not present in nums. Smallest positive integer that is not present in nums, and you must implement an algorithm that runs in O of n time and uses O of 1 space. Now, usually who have been doing or who have been giving contest on Codeforces, that's a very common, again, if you had been giving contest on Leetcode also, then also you must have encountered a problem of MEX, right? In Codeforces, that's a very common problem B. Problem B is a very common MEX problem, but it is much harder than what you would have done in your Codeforces. The only reason is that you have to do it in O of 1 space. Normally, everyone can do a MEX problem. Again, MEX is anything, is exact same thing. This is the smallest positive integer that is not present in nums, that is called as your MEX. Now, for example, you can see that smallest positive integer, which is not present here, is, okay, again, positive integers start from 1. So 1, 2, 3 is not there. So I can say 3 is the answer. Here, 1, 2, 2 is not there. So 2 is the answer. Again, 1 is not there. 1 is the answer. So that is your smallest positive integer. Now, first very basic approach is that, okay, I know that I have to go on from the smallest positive integer and I'll keep on going. I don't know where I have to go to, but I will keep on going. So for sure, I will firstly check for 1. Is 1 in my entire rums? I will search for 1s in my entire rums. Is 1 there, 1 there, 1 there? Yeah, 1 is there. Okay. 1 is there, bro. No worries. Try for the next element. 2. Is 2 there, 2 there, 2 there, 2 there? Oh, 2 is not there. So 2 is my answer. So you saw that, okay, I will take up one element because I know starting from 1 itself up till, I don't know what is the end point, but up till infinity, I will be searching for this specific element in my nums. So considering that these number of elements are, let's say, z, I have to search this each element of z in my array of nums of size n. So each element searching will be n. Searching one element in this entire array of size n will be n. And for sure, if I have z elements, it will be z into n. Now, the question for you might be, Aryan, what is this z? So one thing is very obvious is that, okay, what up till width, actually is it going up till infinity? I will say no. Why no? Because if you remembered, the array size is n. The array size is n for us. Now, what I mean by array size is n, what will happen? The smallest positive integer that is not present in nums. Now, if I give you a worst possible case, every integer, every small integer is present in nums, which means if I say 1 is present, 2 is present, 3 is present, 4 is present. So every small positive integer present. So maximum integer which is not present is n plus 1. So for sure, this can go at max up till 5. That's it. Which means n plus 1 is the maximum limit for it to go to. Else, because it's a simple pigeonhole principle. If I have n elements, they will have to occupy n places. That's it. If any other extra element is coming in, that will actually be, again, I'm just complicating by taking a term pigeonhole principle. You can simply understand, okay, you have these places, but again, technically you should know, okay, how actually things are being useful. But that's simply how we can say that, okay, a new incoming element will be added outside of the range of our array, and thus the maximum, it will not go up till infinity, it will go up till n plus 1 range, which means the n plus 1 is the maximum element which can be your smallest positive integer which is missing in your array nums. Cool. Now, so we got to know that, okay, it will be roughly O of n square. O of n, I will have n elements I will have, and in worst case, I will be searching for all these elements in my array nums. So it will be O of n square and no space, extra space used. But for sure, you see a term, I search for an element in some other array, as in this specific array. So why not? If you use a word search, why can't you simply sort this array? So I will do simple one thing. I will firstly sort this array. My array will become like this, -1, 1, 3 and 4, and then I can simply say, bro, I know that my range of search is, again, my range of search is 1 up till n plus 1. I will keep on searching this element Okay, I'll check for 1, I'll check for 2, I'll check for 3, I'll search for the element 2 in my array nums, but now searching will take O of log n time because it is already sorted, and thus it will take O of n log n time just to sort it in the very beginning, and then searching of every n element in this entire array will take a log n time. So it will be entirely O of n log n as a time, and for sure for Python it is O of n space by default, which takes off the sort, and for Java and C++ it is O of log n. So that is the reason it is in the very beginning told that it is an unsorted array. So you have to sort it. You will have to spend your complexity on your sorting. Now again, for sure O of n log n is still large. Can you do improvise it? Yeah, we can. We know that what we were doing, we were searching for an element 2 in our entire array which is already there. So I know if 2 is actually in my entire array, which means if 2 is present, which means is there or not. So I can simply take a map or an unordered map or a hash map, and with that hash map I can keep track of, okay, what element is present in my array. 3 is present, 4 is present, -1 is present, 1 is present, and so on and so forth. So with this I can go and search, okay, is 1 present? Yeah, 1. Again, checking in a hash map is over 1 time. So I know, okay, 1 is present. Then 2. Is 2 present? Yeah. Oh, 2 is not present. Oh, if 2 is not present, which means that this is your MEX. So you know that you will be, firstly, you will be doing a pre-computation of using this hash map, and that is what you are actually using in your contest of Leetcode and Code Forces. You are using this approach. You are not going on to other approach optimization because it's a contest. In contest, space is not that much useful for us. It is in the interview where the space part will come in picture, and that's the reason people who still solve this problem still are actually stuck in the interviews, because interviewer demands a space optimized solution which these folks who give contest cannot think of. So it's a reason that contest is something different and this is something different. Now so I'll go and check for 2, and it is not present in my hash map. And again, checking in a hash map is a O of 1 operation. It is absent in the hash map, so for sure this is my answer. Thus you saw that O of n is taken for making your building up your hash map, and O of n is just searching those n elements in your hash map, and thus total time is O of n. And for sure you are using a hash map, thus the time use will, space use will be O of n. Now this is very standard, very basic. But can we optimize it? Yeah, we can, because the problem itself asks us that please solve it in O of 1 auxiliary space. Now how we can do it? If you had remembered yesterday's problem, which is problem 442, if you have not watched it, I'll highly recommend go and watch. Again, just write on YouTube Leetcode 442 by Aryan Mittal. You will get the video right on the top, else I will try to put it in the description and comment also. Now usually what we are trying to do, we are just trying to see, bro, I just want to see if something is visited or not. If you just look for very carefully, I'm just trying to see if 1 is visited or not, if 2 is, actually I'm trying to see if 1 is already there in my array or not. Or I can directly say, okay, is 1 already visited or not? Because you can see 1 is visited, okay, 2 is not visited, so it is the actual culprit for me, which means it is not present for me. So if you had gone back to your basics and if you had remembered that how we actually monitor stuff, so if I have an array and if I have to keep track of, okay, what element is visited or not, so in actual more optimized term, what I do is I make an array again where indexes represents the element value. So 1 is visited, so I'll go into my visited array, index 1, and say it as true, it is visited. 4, it is visited, okay, I'll go on to my visited array index 4 and say it is true. Okay, for 6, I'll go into my index visited and say index 6, it is true, and same for 2. So you can see I use another array, and the indexing of the other array is actually used to just say, okay, if something is visited or not. Now coming on back, that what we can do with this problem, same way, I know I have some nums, I know I have to use, I cannot make a new, in this case I made a new array of size n, but I have already been using space, so I know I cannot use the existing, I cannot make a new space, I have to use an existing space itself. Now to make an existing or to use an existing space, what can I do? For sure, we know that our valid answers are from 1 to n, and which means our valid numbers are from 1 to n, and if so, if all the numbers are present, for sure answer is n plus 1. That's completely fine, that you can return in the end itself, but your valid numbers are from 1 to n. So you have to make sure some way that you should track if some number is visited or not. How will you do it? Simply using the same array itself, as we also did in this example. We use the same array because we cannot make another array, and we also have to keep track of something is visited or not. So what I will do is, okay, element is 3. Now element is 3, I'll go on to the index again. Make sure, remember, these numbers are 1 based, but our array is 0 based, so I have to reduce the number, which means element 3. Actually, I would be going on to index 3, but I know these numbers are 1 based, so I will have to subtract by 1. So I will actually going on to the index 2. I'll go on to index 2, which is this index, and then I will say I will have to do some sign modification. Aryan, why only sign modification? Because I want to know if something is visited or not visited. Now in this case it was very easy because all the numbers were positive. But Aryan, if you are doing the sign modification, then okay, you will go on to index again. The value is 3, so ideally I would have gone to index 3, but I will go on the index 2 because it is, these values are 1 based while my indexing is 0 based. So I'll go to my index 2 and I should ideally be doing a negative sign, but you can simply see that the number is -1. So if you do a -1 of this existing number, -1, so it will become a +1. It will become a +1. So how will you even able to identify if this number was, if this index was, again, this index represents this specific number 3. How will you even in future be able to identify if this number, this index 2, which means the value 3, have been visited or not? You will never be able to figure out, because something will be positive, something will be negative. How will you say, okay, what is positive, what is negative? How will you identify stuff being positive or negative? You would not be able to. So that's an issue for me. But considering this issue aside, again we'll look onto this issue, but considering right now this issue aside, what we can simply say, okay, if the value is 4, I'll go into the index 3 and I will put that number as negative. Okay, I'll just put that number as negative. Okay, if the index is 1, again, if the index is 1, Aryan, here the index is -1, so shall I do a -1? No bro, -1 represents that I have put in a negative number to it. Bro, it can be confusing. Aryan, here you did a +1. Bro, ignore this. Imagine right now all the numbers are positive. Imagine that fact. I have taken this example specifically. Again, you will see every example I have taken is considering the fact that I will resolve all your doubts. So considering right now all the numbers are actually positive. If all the numbers are positive, then for sure, if any number you would have visited that specific index, which means that value 4 is visited. Again, this number being negative represents the value 4, which means index 3 represents value 4. Value 4 is visited. This negative sign represents that. Actual value of this number was still a 1. So I'll go on to index 0 and will put a negative sign, which says, okay, negative sign of this number says that the index 0 is visited. Index 0 says number 1 is visited. So I can simply say that I have number 1 in my array. Now, coming back onto this -1, how to handle this? For sure, it is not valid for me. It is not a valid number for me. I know valid numbers for me are from 1 to n. Although this number -1 is invalid. So I should -1 is an invalid number. I cannot transform this number to a valid number. I cannot say, okay, put it as a 2, so that next time, let's say my number 3 would have come in. Again, number 3 would have come in, so 3 would have gone. Again, I'm taking absolute number because I'm concerned about the value itself and not the sign while marking anything as visited or not. So I'll simply go and check for this specific index 2, and I can simply mark that as visited by saying a negative sign. Now you will say, Aryan, why can't I put a -2? Because -2, when I will be at this specific index, I will say, bro, -2, take an absolute value 2, go on to index 1, and index 1 say it as visited. So even when 2 was not present in your array, still you marked your index 1 as visited, which is wrong. So the number, again, coming on back, it was by default a -1. So you have to, again, this is not a valid range. You want the numbers to be positive and in the range from 1 to n. That's a valid range for you. That's a valid numbers for you. So this is not a valid number for you. You have to mod again. And you also cannot take a negative number in your entire array, because negative numbers in your array represents the sign had been changed for it, and so you have to replace this also, and you also cannot replace this with a valid number. So what's the next valid value? Okay, I got to know that okay, I have to put some other value in this which is not valid and also should be positive, because if it is negative then there is no use. I might get confused with the sign if the sign I have put in is my sign or his sign. As in, my sign is if I am just visiting it, in his sign is it is already a negative number, so I have to replace it with a positive number, and it should also be not valid so that I am not confused with okay, oh it was a 2, so I am making the index 1 as negative, so I should not do that. So I will take a number which is a not valid. A not valid number, you know, the valid numbers are from 1 to n range, so not valid number are from minus infinity to 0 and n plus 1 to infinity. But Aryan, n plus 1 can also be an answer, right? Yeah, n plus 1 can be an answer, but n plus 1 cannot be inside the array. What I mean? Let's say your n is 4. So I am saying that n plus 1 can be an answer. N plus 1 can be the NEX, which means if the numbers are 1, 2, 3, 4. So n plus 1 can be the 5. 5 can be your answer, but 5 cannot be inside your array. How and why? Because if 5 is inside your array, then your answer will be a 4. So I know that before even reaching the end, my answer will actually be returning a 4 itself. So I am simply saying that n plus 1, again, any value I can keep inside my array, but if I can simply return back before even reaching on to 5, so that's my answer. So I got to know that my valid numbers inside my array can be from 1 to 4, and that's a valid numbers. And for sure, if it has some number is not there, so that's the answer. If all the numbers are there, then n plus 1 is the answer. That's a simple condition which I know and I will keep in mind for sure. If you want a safety, you can do a n plus 2 also. It's totally up to you. You can take any positive number in this range. I simply took n plus 1 just for it's my choice. It's my choice. So again, you can take a n plus 2, n plus 3, n plus 5, n plus 50 also. That's totally up to you. So I realize that I will do one thing. I will replace all these existing negative numbers to a n plus 1. So what will happen to me? Something will happen that okay, I replace this number minus 1 to a number 5. Now this was the step 1. So you saw what happened in step 1. Step 1, I replaced all the negative numbers. And again, when I say negative, I also mean 0, because 0 is also not a valid number for me. So I replaced all of them to actually a n plus 1. Now comes the actual part of step 2, where I will mark these numbers as visited. What all numbers I have visited. So I have visited a number 3. So go on to index 2 and put it as negative. So I'll put it as negative. Now I have visited value 4. So go on to index 3 and put it as negative. I have visited index 5. Index 5, which means I will go again, if value is 5, so I will take absolute, so value is 5. I will go on to index 4, but index 4 is not there, so I might get null pointer exception. So make a if condition. If the value is actually more than equal to n, more than equal to n plus 1, bro, simply move on, bro. That's not for you. That is not for you. That's not a valid value for which you should put the indexes. So I'll have a simple condition that I will be marking this sign and stuff only when if the absolute value of the number is less than equal to n. If it is more than n, bro, that's not a valid thing. Please, bro, simply move on. So I realized that okay, I will simply skip because the absolute value of this is actually more than my n. Now, if I'll go on here, absolute value is 1, I'll go on to index 0 and I'll put it as negative. So now my final array become a minus 3. This will remain as it is, which is 4, and this will become minus 5, and this will become a minus 1. Now, if I ask you, what is the smallest positive integer which is unvisited, or which is not visited, or which is not there? You will say okay, index 0. Now index 0 being negative means that, again, this negative means that the index 0 is visited. Index 0 means value 1 was visited, and value 1 was visited, which means value 1 is there in my array. So index 0 is negative, which means value 1 is in my array. Index 1 is positive, which means value 2 is not in my array. So value 2 is the first smallest positive integer which is not inside my array, and that is the reason it is my answer. So I'll simply do the exact same stuff. First operation, as you saw, the first step was converting and getting all the negative numbers, which is less than or equal to 0, and converting that number to n plus 1. Exact same this specific for loop. So I'll use this specific for loop. I'll go and check for all the numbers less than or equal to 0 and put that as n plus 1. Again, for your curiosity, you can put it as any value, which is n plus 10, n plus 5, whatsoever you want. Now, next step I saw and I showed you is that I went on to all the numbers. For a specific number, I will reduce the value by -1. This is nums of I minus 1, and I will go on to that specific index, which means nums of I, let's say this is the element, so I'll do a element minus 1 is the index of a specific nums value, and I'll do a multiplication by -1. I'll replace or basically modify that sign. So you use the exact same stuff, that I'll check firstly the absolute value should be less than or equal to n, because I don't want to deal with the more values which I have already modified above, or maybe they're already by default more. I will not handle with them, and I will say grab that specific index, again grab the value, take its absolute value, reduce -1 to grab the index, go on to the specific number and do a sign negative, modify its sign, and that you can see will be your answer. And again, as you saw in the very last, that I went on to all the numbers from sequence from left to right, and then the first index whose value is actually not there, whose value is positive, is my culprit, is my not present value. So I'll simply say that it is positive, so it is not present, so that's the reason it is the answer. So I'll go on from my left and I see, okay, first value which is not present, that is actually my answer, and answer is nothing but I plus 1, which means index 1 is not present, so value 2 is not present. So value 2 is not present. So now you might think, Aryan, this is absolutely correct. Shall I submit this? Yeah, bro, you can submit this, you'll get the wrong answer. Aryan, you told us wrong answer. Bro, see, that is what we learn from our mistakes. Now, it seems absolutely correct, but there's one slight case missing, and that's the reason I took another example, which is this. What if the elements are missing? Now, whenever you have any element, what you are doing is you are going on to a value 1, and then you are saying, okay, value 1 says index 0, and index 0 whatsoever is there, put the sign as negative, which represents it is as visited. Now, again, 1 came in, so you will go on to index 0 and again put the sign as negative. Already it was negative, it will become a positive. So even after 1 being there, your answer is saying that positive, and positive says it is not visited. But in our case, 1 was just visited twice. So visiting something once, it's good. Visiting something twice, I am actually modifying my sign back to positive, which is actually inferring me that, okay, it is not visited, which is wrong. So I should do one thing. If something is already visited, which means if the sign is already negative, please don't change the sign back. So if sign is already positive, if sign is already negative, please don't change the sign back. So I'll do a simple modification that please bro, only change the sign. Please bro, only change the sign when the sign is positive. Change the sign only when the sign is positive. So I'll change the sign only when the sign is positive. If the sign is negative, which means it is already visited. And that's the reason how you can simply solve it. Again, the time used is O of n, because you are doing a simple 3 for loops, O of n, O of n, O of n, and space is used O of 1 because you are not using any extra space, but you are modifying the existing space. Now, modifying the existing array nums is never a good option, and you must ask your interviewer for sure, always. But in this case, as in the previous example, if you had remembered, I told you a technique in which you could have got your previous nums array back, and that was again for sure completely fine, considering you would not even have to ask your interviewer that, okay, do I want to modify my input array or not, because you were actually able to get back your input array. But in this case, you remember that how you were able to, like how you got it, like you had your input array as 3 4 minus 1 1, and you got your output array as where is this gone, you got your output array as -3 4 minus 5 minus 1. Okay, 3 4 minus 1 1, that's completely fine. If I would have said all the numbers are positive, I would have grabbed it. Okay, put a okay, it's a -3, so put a 3, that's completely fine. 4, okay, 4 minus 1, okay, it's a 1. But what about this number? This is completely changed. Even if it would have been a -2, still you would have put in a -5 for it. So there is no possible way to backtrack from the original value, from the final value to its original value. There is no possible way. There is no possible way. So what's an option? Sorry, there's no option. So what you figured out was that this specific way, okay, it's great, but it is actually modifying your input array. It is using O of 1 space, but it's modifying your input array. That is absolutely wrong. Like, not absolutely, but that is, if your interviewer don't want, okay, you cannot do anything. And that is not even like values are rearranged. No, values are just completely changed. What if the interviewer want to know what was the original value inside? Maybe -2 was there or not, he wanted to know. He will never be able to know that fact. So what's the optimal, like what is the way for it? Okay, we have another way for it, and again, that's the thing which most people don't and never discuss. Again, this is the intuitive way. Next one is actually the most optimal way. Again, in that way itself, your value will still cannot, like if I ask you what was the value at the index, what was the value at the index 3, you will still not be able to find out that specific value, but the values will be preserved. The order will not be preserved, but the values will be preserved. So the next way which we will see is a bit better way in comparison to this way. Again, it is not the most optimal way, and there is no optimal way. That is the most optimal way which I'm going to teach you next. But it is much better than this, because in this the values are completely changed, while in the other way, which I'm going to tell you, which is cycle sort, in that the values, again, you can also try, if you understand cycle sort, you can also try this problem with the cycle sort also, but I did not teach it because the most optimal way is much easier than the standard algorithm. But with the cycle sort also, your order of element will not be preserved, but the elements will be preserved, which means the order can change. It can become a 3 - 2 4 1. It can become like this, which means the order is not preserved, but the elements will for sure be preserved. That is the benefit of your cycle sort. Now, as you can simply see that what we have to do, we have to achieve two major things. Firstly, we will have to use the existing array itself. Secondly, we have to actually preserve the elements also. We cannot change the elements. So one thing we can do, we can reorder the elements. If we cannot, like Aryan, but how will you still mark things as visited? Like earlier, you were using signs to mark things as visited, but how will you do in this case? Now, in this case, yeah, it is actually not possible, but I can do one thing. I know I have to make sure of something as visited or not. So I can simply say, okay, 1, the value 1 should be at the index 0. Okay, value 2 should be at the index 1. Value 3 should be at the index 2. Okay, if some value is not at its corresponding index, so if some value is not at its corresponding index, that is missing. So now, for to know something is visited or not, I will try to bring him to its exact position. And that will actually help me. So ultimately, you will see that what and how your answer will look like is after doing your entire algorithm. I'll show you what the algorithm is. After doing the entire algorithm, I will see that I will go on to my entire array from left to right, and then I will go and have a quick check. If nums of I, if it is not equal to I plus 1, nums of I is 1. I is 0, so I plus 1 is 1. So if that is not matching, which means that is my culprit and that is my missing element. So I will simply return my I plus 1. Now, seems great. Let's see. But Aryan, what was the intuition? Intuition was that I cannot use sign. I have to take any parameter so that I can figure out that this is linked. These two elements are linked, which means 1 is present, 2 is present, 3 is present, and the order they are present. So as to maintain the order, okay, 1 2 3 sequentially all are present. So I just took, okay, 1 2 3, I just put them in the order itself. If something is missing, it was missing in the order, and that's the reason I can easily able to figure out. Again, it's a hard algorithm, that's the reason it is actually marked as hard itself. Now, coming on back, we know that we will simply apply lastly this when we have applied as cycle sort. But how are in this is going to be applied? Simple. We know that we will have our numbers, and in this example I have covered all the possible cases. One possible case is number is negative. Other possible case, as we saw, numbers are duplicate. If you remembered, I can have duplicate also. That is the question which we saw. We can have duplicates also. We can have negatives also. So I have considered all of them in one example. Okay, and also what if some number is missing? That is going to be my MEX. Now that's my array nums. Now coming on, what I will do, I will simply, again, remember the aim. मकसद नहीं भूलना है. Our aim was that this one should come to its correct position. But Aryan, I am currently at the first index 0. So shall I go and search for element 1 which should come here? I'll say no, bro. I will simply keep on moving. If I got some element which needs to come at this location, he will come automatically. So what I will do is, it is a minus 10, not a valid number for me. I don't, because it's not valid for me. It's not valid. It's not valid. Aryan, how you know a number is valid or not? For sure. If a number is more than equal to 1 and if a number is less than equal to n, that's a valid number for me. If number is outside this range, it is not valid. So I should not worry about that number to place him at its right location, because that's never be gonna in the array itself. So I will simply move on. I moved on. Now I went on and reached on to value 1. Value 1 should ideally be at the index 0. So how I can make him reach there? I know that the value 1 is there. I know where he should be. He should be at the index 0. So whatsoever, I am currently at the I means index 1. So I know this value, which means I know I know nums of I also. I know that nums of I, where he has to go, it should go to nums of I minus 1 location. And I would also know that existingly what is the value at nums of I minus 1 location. So I should just simply swap them. Okay, 1 should go here. Now where minus 10 will come? He will come at 1's location. So I'll do the exact same stuff. I know this is a valid value. I know that he has to go to some location, which is nums of I minus 1 is the location, is the index where he has to go to. I'll simply swap these two values. So I'll swap nums of I with nums of I minus 1. Nums of I minus 1. Nums of I minus 1 will give me the expected index of nums of I, which is 0. And this is the nums of I. Nums of I is the original index of nums of I, and nums of I minus 1 is the expected index of nums of I. So I'll simply swap them, which means I'll swap nums of 1 and nums of 0. So what will happen with this is that minus 10 came here and 1 came here. Now I'll simply keep on moving. Now what you saw will happen with this is, you simply figure out one simple fact. Again, this last loop you saw was originally, I showed you in the very beginning, that ultimately if you had done your cycle sort, you will simply iterate on. Now with this simple fact which you did here, you roughly know what is happening. You know that, okay, where is this gone? So you know roughly that what is happening is, you are going on to all the indexes. If the index is inside your range, which means if your nums of I is more than equal to 1 and your nums of I is less than equal to n, then you simply are swapping nums of I and nums of I minus 1. Okay, that is the simple thing which you are doing, and that's your answer ultimately. And ultimately you can simply see, you will try for all the possible values of I and say if it is there, then simply return I plus 1. If it is not matching, simply return I plus 1, as I showed you above also. And ultimately if all the numbers from 1 to n are there, simply return n plus 1. As I showed you, okay, if n is 4, 1, 2, 3, 4 is present, so answer is 5, which is the MEX. You might think this is correct. Actually, this is also correct, but there is a small issue in this. What's an issue? You will see first issue is, Aryan, why are you using while loop? And if you're using while loop, why don't you think for loop, while it would not be of n square? Firstly, I will not use while loop. You will say I'll use a if loop. Okay, bro, you are saying to use an if loop, if condition, not a while loop. So one very basic thing is, okay, why Aryan you were using while loop? Or say use of while loop. And other question is, if you're using while loop, which you will tell later on, why will it not be of n square? Are we not increasing the complexity? I'll say one thing. So firstly, why we are using while loop and not if loop? If you simply try to, again, I always say, always try stuff. Use if loop and see your code fail, and then try run, and then say, oh, that's the reason I need a while loop. So basically what happens is, okay, value is 3, you will go on to index 2 and do a swap. So minus 1 will come here and index 3 will come here. Now your I is at index 1, so value is 4. It should actually swap with index 3. So it should go at the index 3. At index 3 it should swap. So basically 1 should come here. So okay, 1 should come here, and then 4 should come here, and then ideally your I should again move. But if your I moved, you will see the 1 is not at its correct location still. 1 needs to be at index 0. So 1 has to also go back at the index 0. It should again do a swap. It will come here. Now minus 1 is here. That is the reason you actually saw that 1 needs to, it should keep on swapping until because see, in the next step, you know your I will move. In the next step, because you know your I is for sure moving. if I just erase this, your I is for sure moving. If you just did a one swap and you moved on, your I, if you would have done one swap and if you would have moved on, you would have moved on your I later on to here, which means your one would never be at its correct location. So you would have marked that, okay, bro, 0, I found something which is not equal to 1, so that's my first positive integer value which is missing, which is 1. But that's incorrect. So you know that you have to keep on swapping. If your number is at this location I, you will have to keep on swapping until this I is sorted. This I has no other possible value where it can reach to. And the best part is, again, you will see the best part, which will actually help you figure out. Again, first thing is figure out that why if condition will not work. While condition, you will have to have while condition, because you will have to, at the ith location, you will have to make sure whatever is at the ith location should be a non-valid, or if it is valid, then it should be at the ith location itself. Then I can actually move on to my next I location. So with this fact, I got to know that why my while loop is actually necessary. Now your question will be, Aryan, if I'm using a for loop and a while loop, it seems like it will actually keep on going and will try. Okay, one thing is for sure, that this loop which you have written will actually go to the infinite loop. So for sure, this will actually go to infinite loop. And which means, okay, no n squared, no n cube, no exponential, it is actually infinite. Aryan, how you found that? Because if you remembered that, okay, you are actually looping things up, which means things will keep on coming. But did you ever think of that? What if you had, again, I show you that how you can think of that. But if you just keep on continuing your existing dry run, you are at I. Its location should have been at index 1, so it will simply swap. Okay, -10 came here, 2 came here. Now your I is here. Its location should have been at index 1, but it is already there, so you will swap it. But 2 will come here, but then 2 wants to go at 1. So you saw an infinite loop bringing in. Because of that infinite loop bringing in, bro, if you keep on swapping the same thing which is already at its correct location, you will go to infinite loop. So I will have to figure out, okay, if I am about, okay, this is the value 2 which needs to go at the location 1. But if location 1 already has its correct value, don't swap it. And that is the trick which actually will tell us that the time complexity is actually O of n. So we got to know that, okay, if something is already there which is already good for us, I will not swap it. So what I'm doing is that, okay, if something is already good, I am not swapping it. So if my nums of, again, this nums of I -1 is the expected index, which is 1, and this nums of I is the original value. If this 2 is same, bro, simply, if it is same, which means at the expected index, I have the expected value, don't swap it. So I'll don't loop it and I should move on. So my condition will look something like, only if the expected index, expected value, if this is equal, bro, quit it, quit it. I cannot go in the loop. But if it is not equal, only then I will be actually looping up. And on every looping up, I'm actually making a correct pair. I am placing the, again, if you remembered, at every looping, I am, again, if you remembered, the 4 was here, the 1 was here, and the -1 was here. So at every looping, again, if you remember, the 3 was here and -1 was here. So at the first looping, I went on and placed my 3 at its correct location. And I know that 3 will never be taken out from here itself. So 3, I will never be actually looping on 3 itself. Now, when I was at 4, so 4 went on, again, in one loop, 4 went on to its correct location. And I again know that after this one loop, I will also never be looping on to this index 3 again. Now for 1, again, I went on to index 0 and this came at 1. So on another loop at the same index, I placed my value 0 at the correct location. so I place my value 1 at the correct location. So I again know that the looping will not happen here also. Again, Aryan, this index is already moved, like your eye is already here, but yeah, that gives me a surety that the looping will never happen here. So at every looping, I am actually placing one of the values at its correct location. At the first looping you saw, the 3 was placed at its correct location. At the next looping, 4 was placed. At the next looping, 1 was placed. So at every looping, something is being placed at its correct location, and I know when something is placed at its correct location, because of the second part of the loop, second part of the condition, I will never be replacing that correct thing. So I know that because of this loop, I am placing something at its correct location. At every loop, something is being placed at its correct location, and because of this thing, if something is already placed at its correct location, it will never be replaced by someone else. So I know one thing for sure, that at every time, and I know I have at max n correct locations, so this will actually in total will go O of n times. Again, you can say roughly O of 2n times, but that is bounded by O of n complexity, and that's the reason its time complexity is actually O of n. Cool. And ultimately, this is the standard thing which you saw above also, and that's the reason ultimately I can simply return my O of n plus 1 if I cannot find my answer in the existing array, which means if the existing array have 1, 2, 3, 4, all the elements for n equal to 4, if I have all the elements, I simply can return O of n plus 1, and that's going to be my answer. Again, the video went to 1 to 41 minutes. You will never find a 41 minutes video on this problem because people will simply skip it, and for sure this video also will not be getting any reach because the video is late. People have already published the video, it's late, it will not get. Again, the video is long, people will skip it. That is the entire remedy for no views, no reach, no subs, nothing. But still, I just think of maybe our audience, like our people, our students get a bit knowledge that not like any video which is just a short giving one approach is not good. You should be knowing all the approaches for an interview. The moment you get this, the moment you will start getting good. Again, spending too much time on a problem is also not good, but it's my responsibility to make the videos for everyone and not for anyone. Now again, the time you will see, again I don't know why this is here, but yeah, again the code is there. The time which you will see for this again is actually O of n. I showed you the proof entirely of O of n also. Space is also O of 1, but again, if you still want the order to be preserved, for sure the space of O of n will for sure be used. But if you think, okay, I want the values to be preserved but the order can or cannot, like that is not a much deal for me, then this is the best algorithm for you if the interviewer asks you to do so. Cool. Bye bye, take care, goodbye. 42 minutes, god damn. Okay, bye bye.